Thank you. Thank you, everybody, for attending my talk. So yes, I will be quick too because Ronnie is reading. And so, okay. So thank you, everybody, for joining my talk. Maybe if you have seen it, I've done this talk quite a few times now. I call it Enter the Brave New World of Generative AI, and with some vector search. And I understand, this talk is going to be a short one, so I'm not going to be having time, to kind of go very deep, but at least I'm hoping to achieve this is to give you an introduction, and presumably too, this is a Java focus type of conference. So presumably too, a lot of Java folks are not into, Gen AI. So I hope to give you a quick introduction to this. So yeah, thank you again to Extreme J, to Ham for having invited me here. And I'm just very happy to be here. And okay, let me go. Okay, here we go. Okay, so really quickly too, this is the agenda. I'm trying to fit everything within the 25 minutes. So a quick introduction and then a brief background of AI, trying to understand the players in this Gen AI era, and then the different terminologies, essentially, right? GPTs, NLP, LLMs, and then getting into vector database, vector search, all these things. And then a quick demo if time permits, but I feel we probably won't have time, but I'll just give you, share with you my resources. And I also have a live stream that I'm hoping to restart, and so when I have it, then I can do more demos if you can join me too. So I'll share with you later. So that's the rough agenda. Very quickly, who's Mary? So really quickly, right? So I'm a passionate developer advocate, I call myself. And so I've worked for different companies, and I've been doing advocacy for about 6 years so far. But before that, I was a developer myself, and about 20 years or so in Java specifically. So I was engineer and working for product company, and then later for, kind of IT organization on the application side, and primarily in Chicago. But I was actually born in Hong Kong and then moved to the US and study, I actually have a math and computer science background. And interestingly, I was going to say I'm doing Gen AI. I'm actually loving it because, as vector database similarity searches, a lot of them are depending on the math theory behind it, like linear algebra, right? All of the vector mathematics is what kind of form the backbones of the algorithm side of things. So that's a quick thing about me. But as far as working too, as you can see, I'm a Java champion. I'm also the president of the Chicago Java Users Group. These days, about 5 months ago or so, I started helping an AI camp meetup too. So yeah, I'm very involved with the community as well. So these are the different things I've worked with, or currently, or in the previous lives, incarnations. And these are the kind of my area of interest too. So without further ado, let me go ahead. Let's say, a brief background of AI first, So primarily too, if you kind of look, a quick kind of history to peep back, into about almost 100 years ago, that's when this, kind of, the present day of the generative AI, in fact, started off. And I say if you go back in history is many years ago, but really the past, kind of 90 years or so was kind of when the focus turned into more of the present day AI that we are kind of on track of this. And how so? Because that started off too with a lot of writing, right? There were already people, writers, authors talking about the science fiction, right? Golden age of science fiction started in about 1938 and so. And then, as you kind of see this particular timeline, and I'm sharing this, and as such, I didn't make this up, but it's kind of, I took it from this link too, if you're interested in it. But if you can see, right, Alan Turing, the modern computing father or founding father of the modern computing, he actually wrote about can machines think, and really that's when kind of the whole world of the computing, as a study kind of discipline, right, started kind of moving towards this area. So all these things, blah, 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 go through all of these. And as you can see, right, the latest too, as such, I work for IBM as well. So I'm kind of also interested to know that there was a Deep Blue that was developed to play chess, and it's dedicated, right, doing, I guess that was using like supervised training type of methodology too. And its job, that particular bot, was to play chess, and it beat Gary Kasparov at the time in 1997. So that was very interesting, the Deep Blue. So that was just a quick thing. So when it comes down to AI, if you kind of think about it, kind of strip down everything else, all the noise, and it's basically all about automation. So if we kind of take a look high level wise, right? Understanding this field. And there's artificial intelligence, that's sort of like the umbrella term. Think of it's kind of all encompassing. What it's trying to do is to mimic the intelligence and the behavior of human beings without us having had to even like, the ultimate goal is without even having us to think about it. Now, the thing is too, is not to say we need to be lazy. And it's very easy to say we can depend on everything ask the bot to do, but remember too, it is only a bot and it's trying to mimic what we think, but don't ever think of it replacing us. We can never be replaced, right? Anyway, that's AI. And then if you kind of look inside further and further in, the first kind of distinctive layer, it would be called machine learning. So that part too is kind of involved the techniques in which the computer will learn from the data without us explicitly telling it to. We basically are training the computer to train itself based on the data, right? And basically is based on training the model from data sets. How does it train? It's basically learn from all the data. So as you can see, the data is almost an infinite amount of data that it needs. And then if you kind of go further deep inside, because just by machine learning, it's not sufficient, how does it actually reason things out? How can it predict what the next word is? All of these things are basically mimicking the human beings, the neural, how do we think, right, in our nervous system? And that's what it gets into. That's the crux of it all. And that's where current day and age, right, generative AI, all of the neural networks is kind of come from this deep learning layer, as we know. So this is that was a famous kind of a shape or kind of based on sort of like a set theory to describe AI. So now let's take a look then into this fascinating generative AI era. What is GenAI, right? So it's a disruptive field in AI. So it has the potential to change the way how we acquire knowledge, how we acquire all the contents and consume it too. And then what it does is it takes these input, right, as what we call prompts now, then turn them into, kind of the responses too. And of course, a lot of things go on in between too. Now, it uses and essentially the combination of the machine learning and deep learning layer of techniques to kind of produce the contents. And notice that, before generative AI, I'd say, it's not all that new, right? AI. And it was actually predictive AI that was more what we were used to before Gen AI. And predictive, so to speak, is, again, Gen AI is also about prediction in a sense. But the thing is that with predictive is that it based on previous data is trying to project some kind of forecast. So as we can see, predictive AI deals more with, let's say, sales forecasts, weather forecasts, like essentially too, the thing that is trying to predict would have kind of time expiration to it. There's a time validity to it too. So like as I mentioned, weather forecast, business forecast, maybe predict the business within 2 years or something, weather forecast within a week or a month. And those things too, as it turns out, right, a lot of times too, it's actually pretty accurate what it produces. But the thing is that it won't be valid anymore if that prediction already kind of expires, so to speak. Whereas for generative AI is that it tends to have much of a durable kind of validity to it because we're talking about more creative type of content that is being generated, like generating code, writing a blog article, composing a piece of music, designing a fashion, for example, something like that, right? It's more kind of on that side of our human beings kind of activities too. So that's Gen AI. So really quickly too, kind of if you kind of take a look at it, I'd say since the new millennium, that's when this generative AI, the effort kind of focusing on that. Because if we go back to 2003, and that's when Yoshua Bengio, they developed the first feed-forward neural network language model. So essentially, too, it's really dealing a lot too with language model, the linguistic side of things, because we want to be able to understand, the language without kind of using things like the traditional way to, so to speak. So as you kind of see too, 2003, then 2011, Apple has Siri, and that was like the first time ever it's actually using natural language processing assistance, right, to the masses by releasing his first iPhone with Siri. And in 2013, actually, this is kind of a kind of fundamental to the current Gen AI, word to vec, and that sort of like form the basis, right? It makes use of a neural network and essentially to have words and essentially convert it, right, to vector. So that's when essentially 10 or 11 years ago, that's when this technique's being developed at Google. And as such too, 2017, if you are into this, field, you might have heard of a paper called Attention is All You Need. And that was the transformer. That's actually to this day is still being used, as the fundamental kind of technology that's actually at Google, right? And it's called the transformer. So that's kind of a quick history of this Gen AI. And let's understand the players of this Gen AI era too. So first of all, let's take a look from the model side. And we have all heard of, right? OpenAI, that's the thing. OpenAI is kind of more like, the company, an entity, an organization, but it's also kind of contributed by many organizations too, with the money too, because they are the ones that produce the, essentially the large language models, which cost, a humongous sum of money. So as such, OpenAI, and it has GPT 3.5, and that's kind of made so famous now, right? In the 2022, the end November 30th. In fact, when it came out, it kind of shocked the world, took over the world too. So GPT 3.5 is the premier one. And then as you can see, there are other types of models. So let's take a look to this BERT, actually before GPT 3.5, Google already is doing, and they're calling it BERT, right? And so essentially, to this day, I'll kind of take a look to is basically Gemini too, is an app side, generative app side that comes out of it too. So BERT's kind of fundamental. And then also too, if you kind of take a look, right, there's also Codex, and that's actually forms the model for GitHub Copilot. Llama 2 on the Llama, that family, they're open source LLMs, and that comes from Meta, or the formerly Facebook. And then there's also Stable Diffusion, right, that came out of Stability AI. That's also changed things because it's really, they developed the first like text to image diffusion model that kind of led to Dolly, Midjourney. I'm sure some of you already are using it, right? That's kind of fun too. You try to generate images and just type in words, describe it, and generate images. And so that's that. And then there's also Whisper, that's more with audio side of things. And of course, there are tons of other models too. For example, companies like Anthropic, that actually they came out of OpenAI. They also have their own model, Claude, or actually Claude is more of an app. They also have their own model. Cohere is another kind of quite popular company, right? Besides OpenAI, that's also developed a lot of LLMs too, called Command and Embed, for example. So those are generative models. But then models won't mean anything without the app. So let's take a quick look, right? These are just some of the apps, right? We already talked about ChatGPT. It's based on GPT 3.5, and it keeps kind of having incremental versions to it and major, GPT-4. And then there's also GitHub Copilot. I mentioned about it. There's also Bard, that comes out of Google, but Bard is, they claim, so they call it, it's more like the new model now is, or new app now is Gemini. What's special about it is that it is a multimodal type of model that, that kind of support the different modes of, either the text or images, text to images, images to the video, however, different modes you have. So it's kind of quite disruptive. It came out recently too, Gemini. And then, well, I should say Gemini already in development, but I think the first kind of usable major version came out quite recently. Okay, and then there are other ones like over here I listed, right? Bing AI, for example, the other companies like Salesforce, there's SEO AI kind of catered for specific types of usages like Notion. Monkey Learn is another text text to vector text type of app to generative app, and WordTune, for example. So these are just a little tiny handful of what's out there. I'm sure there are tons of apps that are out there right now. Okay, so now let's take a look then at the modality side of things. I talk about multimodal and what does it mean? So as such, if you kind of look at it, there are different modes. There are 6 major mode, in this generative AI space currently. There's essentially text, right? And then image, the text is primarily the chat bot, what you kind of work with, like the text. But the amazing thing now is that, for example, Stable Diffusion can do text to image diffusion type of model. And then also recently too, OpenAI came out with Sorrow that actually can do text to video. And as I kind of look at some of it is quite amazing too. You can describe a scene and it generates the video for you. So you can do text to video, or you can kind of vice versa. You can have video and have it describe what's out there in text form, for example, or even output in audio, and then code, and 3D. These are different modality. I think that's kind of seems to be one kind of focus area of this whole generative AI kind of trend too, is to support the different modality. Okay, so how about people, player, right? So we kind of look at it, and sometimes we look at it, and a lot of times too, because it relies so heavily in data, like all of this that's possible because of all the data. Essentially, large language models needs to kind of sort through all of the data and do its thing, and kind of essentially do all the magic. And so data scientists, right? So they are the ones too that know what, the what, concerned with what, right? And computer vision engineer, all of these things. And then is basically too, they are not the ones to execute, right? So in terms of implementation, say for example, we're mostly, I assume you are developers. So it would be up to the engineers, and their new, kind of a role called AI engineer or data engineer that works with the mechanical, sort of like mechanical side of things to kind of implement what data scientists understand the what should be. So, and then there's also new kind of role too. There, kind of, to me, is an extension of DevOps people going into machine learning ops, right? ML ops. And that's also another kind of, kind of a growing area, I believe. ML ops is going to become more the thing, because right now there's actually, if you look around, there aren't much of ML ops, because I think the whole industry is still trying to figure out what it is and what kind of process and infrastructure would be needed, right, to kind of support like smooth operation of this whole field. Okay, so now let's take a really quick look then at all of these, in the kind of quick minute for each. GPT, generative pre-trained transformer. So what it is that it takes prompts in natural human language as input. And notice the natural language, human language. So it's different than what I think most of us are used to. If you're a programmer, we used to be so strict. If you kind of think about it, you need to be able to run something. You have to, let's say, right, for example, a typical Java program or any kind of even scripting, you need to say, I need my, configuration, and then you will pass in parameters like doing, flag 1 is some value, flag 2, whatever, like that. But now, what the nice thing is that you can just talk to the bot like you talk to another person. No need to follow these strict rules. So that's kind of earth-changing too, and being able to understand it. So then from there, then there are also pattern matching, the searchers to be able to search for the, kind of the predicting the next, kind of, if you kind of think of it, right, this whole field is really about command completion, so to speak, right? So like that. So like basically that's what it is called pattern matching, right? The search is not kind of definitive, so to speak, because you're searching for some results that's kind of, that particular context around that particular area. It's a little bit kind of a fussy too, so to speak. But anyway, so GPT, and then it answers questions for the prompts, right? So it produces contents like writing an essay, writing a blog article, composing a song, writing, or designing a dress, for example, is pretty kind of creative, right? That we can see. And GPT started showing up around 2018, and that was GPT. There was a paper at OpenAI, and it's called Generative Pre-Training in 2018, so roughly 6 years ago. And then essentially, too, OpenAI kind of pick up speed. There was GPT-2 being developed, and that's just increasing essentially the documents that it kind of incorporates too. And then very soon, as you can see, right, 2022, as I mentioned, Stable Diffusion came out with text, the first deep learning text to image model too, and led to DALL-E and Midjourney. And then 2022, the earth-shattering, I guess the first earth-shattering November 2022 was the GPT 3.5 that, when it released, it reached 1 million users within like only 5 days. Everybody is mesmerized. All of the business are now trying to gather up steam, thinking of ways to make more money, so to speak. So anyway, as we can see, all of these, this whole ChatGPT continues to. Okay, so now NLP, natural language processing. Now, without this, then there wouldn't be any ChatGPT. as such, right, NLP is an interdisciplinary studies between linguistics and computer science. So it's very fundamental to what is needed by the ChatGPT, this revolution too. And the concern is to be able to process natural language data sets, right? And takes it from text and speech corpora. And essentially too, that's again the magic. If you kind of talk to someone who's new or not too familiar with all the deep kind of thing, you can say, well, it is what's the magic behind all the scenes. And it uses rule-based and probabilistic machine learning approaches, and it enables computer to learn from the contents, right? Including not just learn all of this stuff, but also the contextual nuances of the language itself. And it's kind of ideally to draw insights, from all of the documents. Now, large language models. Now, this is what developers we are mostly interfacing with, right? If we're not like in the data science kind of side of thing or linguistic, and so this is kind of fundamental. So it is a fundamental type of model, and it's machine learning. And typically, the pre-training consumes a humongous amount of time, right? We're talking about these general kind of language models, and of course, private companies, you can develop your own private LLMs too, which in effect is probably a small subset. However, that LLM that you develop yourself or train yourself probably is consisting of private data that's supposed to be secure and not to be exposed to the public too. Anyway, but for these general purpose LLMs, and they need a lot of GPUs because as such, right, it's processing petabytes or even more of data, right? And it takes many weeks, right? It needs to figure out all of the rules and all of these things, and it needs to store them, essentially. It performs NLP tasks, generates and classifies text, and answers questions, right? Just like a human too. It not only kind of answer questions like strictly the old-fashioned bot thing, but it analyzes sentiments and create chatbot conversations. And that's what's been mesmerizing all of us, because it seems as though it can just talk like us, like human beings. Okay, so this is just a diagram explaining the LLM. How does it fit now, right? Earlier we saw that simple set theory. This is still simplified, don't get me wrong. But as you can see, AI, machine learning, right, with all of these, if you kind of drill down deep learning, that's when it's kind of get into the Gen AI. That's where it fits, right? All of the image gen, the kind of GAN and VAE type of kind of transformers in there, LLMs, and that's where it fits in here inside the deep learning side. And it leverages on NLP to help it to kind of sort and categorize all of these information. And then behind it too is really data science, because still there's just tons of data it must kind of churn through. Okay, so now how can I work with LLMs? So I just want to suggest a couple of popular libraries. There are, of course, tons of them out there, but just want to point out LangChain. I believe that seems to be the most kind of popular these days. It only came out 2 years ago, or barely 2 years. Pretty impressive too. They came out, LangChain. And it also has different kind of libraries that deals with different aspects of computing. I think they have like LangChain for LangServe and for kind of more deployment side of things, all of these stuff. Although bear in mind too, these are so new, so they can change, and documentation often isn't too sufficient. You basically, if you're doing that, you have to really sign up with their group and be involved with the community like that. So LangChain, Llama Index, also another very popular, but I think Llama Index deals more too with the retrieval side of things too, from what I've read about. I haven't had a chance to work with Llama Index yet, but that's also kind of very popular. And then there's also semantic kernel, to wanting to point out from Microsoft. There's semantic kernel. They also have a Java SDK to it. And then there's also Palm, and Palm is from Google. So kind of pointing more to Vertex AI too. And then there's also a site called Hugging Face. And if you're interested, well, what it does is think of it like a GitHub for, for AI folks. And essentially, if you go, we can get a free account, and there are tons of LLMs that are folks that are sharing out there as well. So it is kind of a public repository, but that doesn't mean you can use it all for free, I believe. But however, it is being listed in there, and you can find a lot of models in there as well. And so Hugging Face. And then how about Java? This is a Java conference. So let's kind of talk about it. So there's also a LangChain 4J that I would recommend if you're kind of wanting to start looking into it. It's not quite, exactly like LangChain because it is as such is try to kind of model it after the LangChain, but it is as again 4J is very typical Java library, and then there's also semantic kernel. I kind of point out Java SDK in there, and then there's also wanting to point out I worked for DataStax previously, and that was the chief architect. Luke, and he did JLlama, and JLlama is essentially modeled after Llama, but it's called JLlama because it's Java. That's also kind of interesting too. Now the thing is, if you follow my Twitch stream, I'm going to be doing something with JLlama if you're interested in. And then there's also JVector. This one is more of a lower level, kind of what you call they are using Project Panama, and that's also developed by DataStax, the Cassandra original committer too is developed this is basically using Java. But the thing is though, JVector so far is only supporting Cassandra, Apache Cassandra for their vector database search. And then there's also Llama 2, which is actually a port from Llama C. So if you're familiar with that, that you can also consider using. Now, the thing is too, let's kind of quickly show some code in LangChain 4J. So how would you do it, right? So LangChain 4J, essentially this, I took it from their Hello World example. So as you can see, all you need to do, like very often you write code like this, you want to have an API key for OpenAI. And that's where you can then connect to that language model. And then after that, then you can just do a model generate, in this case, generate a hello world. And it's basically it gives you the answer. It's basically, it comes back with, hello, how can I assist you assist you today, right? Like that. So I don't have time to run it now, but just wanted to quickly kind of show it to you. So as you can see, really quickly, hello world can be done quite quickly as well, but make sure you have an OpenAI key with you too, everywhere you go. So, okay. And also just to point out too, OpenAI, there's GPT 3.5 that's actually mostly much less expensive than using GPT-4. So just something to point out to you at this point. So, okay, now I probably have 2 minutes to talk about vector database and vector search. And what is vector database and why is it so important in GenAI? Essentially, it's a purpose-built database that serves up vector data type for complex machine learning purposes. And the thing is, too, what makes it possible is that you do need to convert all of your data into what is called embeddings. Embeddings, essentially, too, if you look at it, is basically an array, some sentences that comes in, it gets converted to some numeric representation. And what it is being stored as is basically arrays of floating point numbers in there. So if you kind of look into a vector database and select a vector database column, you notice that it's just numbers after numbers of floating point numbers. And that's what is being translated to. And why is it so? Because it enables to do linear algebra computationally more effectively than if you have to do it in strings, directly in string. Can you can kind of know, kind of figure out where I'm getting at. So that's what it is. So essentially think of it as like a form of, in machine learning language, is called feature engineering too. So it leverages on a technique called approximate nearest neighbor, ANN, in there. So if you let me kind of take a look now. So mechanism, what is a vector embedding, right? So if you kind of look into vectors as two-dimensional, kind of normalized kind of representation, so this embedding model would transform a text, into a vector called an embedding, right? This embedding can be however many dimensions that is supported, and OpenAI's embeddings are 1536 dimensions. And I think the newer version, I think GPT-4 might be like 16,000 now. So anyway, so really quickly, just to understand it kind of pictorially. Basically, look at them, all of your vector. Now look at, if you're a math inclined person or expert, right? Vector is not just the dimension, but it's also, it's kind of represent a dimension. So not just the actual, value, but it's also what is called a direction. So that's why we're using like a graph to represent it, on this two-dimensional pane. And so if you can kind of see, vector 1, vector 2, vector 3, they're on different points on this two-dimensional space. Now, the thing is, this is kind of another example that kind of gets a bit closer to what maybe it's easier for us to understand is if you kind of have a cat and a dog and a house, they get represented in different points in that space. So as you can see, if I'm like searching for something that's closer to a cat, then it would be a dog because well, as such, they are of the same category. So they do kind of like get kind of placed, or translated in a way such that, they are closer to each other if they are of equal kind of a closer kind of category too. So like that. So the dimensions are basically, these are result from the LLM training itself. So now this is just a really quick kind of like introduction. I know I'm kind of running out of time, but the thing is too, wanting to point out, there's vector stores, vector databases, all of these things, as I mentioned to you, right? There are different like nearest neighbor embeddings in there. So if you're interested, you can kind of get more into it. But again, this is just to give you a very quick hint of how this whole thing works. It is the vector database similarity searches. Okay. And so what other things are vector embeddings being used for? For searches, for clustering, for product recommendations, anomaly detection, diversity measurement, classification. So it has actually used not just for kind of machine learning, kind of specific type of uses, but if you have other things like shopping cart, you can think of using vector embeddings as well. Okay, so problem with traditional database, right? So now we talk about vector database. The traditional database, you can also use that, but I bet it would take much longer because how do you handle data that's supposed to be catered for multi-dimensional type of uses, right? You need to, in machine learning kind of lingo, you need to figure out the data, how does it, kind of relate to one another, the relationship, the patterns, and all of these things. Okay, so this is just an example of what is called a RAG kind of AI applications and where the vector database sits, right? So again, I won't get into all the details, but I'll be sharing with you this slide so you can take a look at it too. Okay, so very, very quickly then benefits, right, of this whole Gen AI thing is basically think of it like you can ask and you can always receive, but make sure you ask the right way. And that's kind of the trick to this whole thing, right? Work being done for you by the bot. However, there are challenges too. There's hallucinations, and I think that's more common. Is basically if the LLMs doesn't have answers for you, instead of telling you or saying something right or saying I'm sorry, it might give you the wrong answers. So it can do also damages too, so be careful. And also there are ethical concerns, potential misuse, so please pay attention. There are no oversight or anything kind of overseeing the usages. And how about real-time up-to-date data? So LLMs are trained, but it's taken data from old, for example, GPT 3.5, they took data up to only 2021. So what to do with that time between then and now. So you might want to consider using a pattern. I think you might have seen it's very popular now, retrieval augmented generation, this pattern, and it's everywhere now. So that's what is being used for LLMs to supplement what LLMs kind of lacks. Okay, so I think I'm kind of time's up, so let me share with you quick resources. This slide deck can be accessed here, and I'll also share it with Ham and also with the conference too if you miss it. So, and then also I have my stream I mentioned about. I usually try to do it Wednesday, Thursday, or Friday afternoon, but I sometimes get kind of busy with travel or with my kind of activities. But otherwise, please follow me on Twitch TV or my YouTube channel too. And then with that, I want to thank you very much. And again, I think I may be going over time, but but thank you. I wanted to say thank you. And this is how you can stay in touch with me. My LinkedIn profile, my X or Twitter handle, and also I have a Discord server as well. If you like to kind of ping me, and I usually am responsive, I'll always respond to you. So thank you very much.